of this loop and how we dynamically allocate an array of pointers and how we get rid of an array of pointers after we're done with it. I also want to get into, we may not do that until Wednesday, get into this notion of a function pointer, because they are quite important. All right. So this, we talked last time, string token generates a series of strings each time it's called, generates a space, in this case, whatever is in delim is the delimiter. String token will return us the string that is just before the first occurrence of whatever delimiter is. And we say while it's not null, when it's all done, string token generates a null here. And so while we're not done, so on this one, I suppose I should shut down that. Sorry. While we have no string token doesn't give us a null, we'll output whatever token pointer is, which is the first word, for example. And then this thing does what?
Allocates, instantiates.
Here's process string. And what does it do?
It allocates and instantiates, creates an instance of.
Of what?
The object or the structure.
What's the data type of temp? What is the data type of temp?
Pointer to a pointer.
It's a pointer to a pointer, and because of the square brackets over here, can we say anything more about pointer to a pointer? Dwight?
It's an array of pointers?
It's an array of pointers. How big is it this time, which is the very first time we're coming into it?
1.
Okay, so num names is 0, so it's an array of length 1, but nevertheless treated like an array, allocated like an array, and its data type is star char. Okay, so it's an array of pointers, and temp then points to what? What does temp point to? Jeff?
It points to the address of temp. The address of temp.
So temp points to the address of the array
Right.
that we just allocated. Okay? Is there anything in that array right now? Daniel?
No.
No, not yet, right? You found that out yesterday. Okay, so when we are dealing with that, temp now points to, drawing a picture may be helpful. Temp points to this array, there it is, one cell long, and who knows what's in it? Is that clear? Then we go through this for loop, and how many times will we go through the for loop?
Num names.
First time, not at all.
First time none at all, because I starts off at 0 and num names is 0, and 0 is not greater than 0, therefore we skip the for loop altogether the first time through, right? And then what do? What's this long thing actually saying? Justin?
Just
Other Justin.
Now you're actually assigning space and temp num names and an address.
Okay, so the right-hand side is allocating the space. How much space does it allocate?
This 1, 4.
I don't actually need a number because we don't have a value.
Enough plus 1. Enough space plus 1.
Enough space plus 1, and enough space is this token pointer, whatever token pointer, the length of token pointer was, right? It's a character string, not including the null. So we get the string length of that, plus 1. That's a chunk of character bytes, the address of which is passed or returned back to num names, or excuse me, back to temp sub num names. Now, is there an alternative way to state that? Kenan? If I said, thou shalt not use array notation, how can I say that?
You go splat, pairing, temp plus names and
So, splat, parent, temp,
plus num names.
plus num names. Is that it? So we take temp, which is pointing to this array, and we offset it by, we add to it num names, which in this case is 0, first time through, and then we dereference that. That's an address, right? So we go to that spot, which is right here, and then assign this address that we just got into it. Clear? They are identical in terms of their action. I'm going to comment that one out. I want to leave it there for the moment, though. So then, the next thing we do is what? What's the next line here? String copy. Keone, what do we do here?
Take the content of the token pointer
The content of token pointer,
and put it into temp.
put it into temp square bracket num names. Now, could I use this notation here instead of what I have? Yep, I could. Exactly that same notation. And we're still pointing at this spot. Okay? So, as a result of that, let's pretend that we had Mary allocated. And token pointer is pointing there. Then we copy this address into here, so that is also pointing there. Is that right? So what happens? Max? Is that what happens with this statement?
I haven't followed along too well.
Okay. So somebody else that has been following along? Tyler?
Basically copying the whatever is held in token pointer over into the array.
So this isn't what happens, is it?
No.
Not at all. What actually happens here, token pointer is there. That's just fine. But we also allocated 1, 2, 3, 4, 5. We allocated that, and this memory location, temp sub num names, is pointing to this memory location, right? And we don't know at the moment what's in there. There's just some memory. 1, 2, 3, 4. Got one too many. And then the string copy actually copies M, A, R, Y. Does it copy the null? Does string copy the null? Dwight says yes. Okay. We clear there? So far, so good. We have an array of 1 pointed out by temp. What happens next? Delete num names. Square bracket in front. But num names doesn't point at anything, does it?
It's names.
It was initialized to
Zero.
names, I'm sorry. It was initialized to, well, here it is up here, excuse me, but when we made the call, names was 0, right? Now, there's something going on here we need to be aware of. It's never a problem. You will not get an error if you try to delete a null pointer. C++ won't squawk at you. Okay? So, at this moment, names is pointing at nothing. It's 0. And trying to delete what it points at is just fine, because there's nothing to delete. C++ is fine with that. Is that clear? Okay. So, we do that, and then names, which is now, at the moment, 0, its content is 0, we copy the address, and now temp and names both point there. Okay? Clear there? Next step, add 1 to num names, and this one is just searching through the array, and it'll find the first one and compare token pointer in this and set found to true. Just building for a little later where we do a search to make sure, checking for duplicates. In any event, we can effectively ignore those 2 lines for the purposes of our discussion. And then we get the next one. String token gets the next one. Num names is 1, so we come back up here. Assuming there's still stuff in our string, token pointer gets the next thing. We print it out. We do an allocation. Now how many do we allocate? 2, right? Because num names is 1. We've already got Mary in there. This thing is pointing to Mary. And we have an allocation for 2. Temp is no longer going to point here. This thing is still pointing, isn't it? The thing is still pointing there. But now, temp is pointing at something that's 2 pointers long, an array of 2. What do we do next? So we get the allocation of an array of 2 pointers. And now what do we do? Ian? No idea? Andrew? No idea? This for loop here does something. What does it do? Daniel?
Does it put the address of names in a temp? that
So
it holds?
all the names that are in, all the addresses that are in here now go in here. But wait a minute, there's only one address here and there's 2 spaces here. Problem? No, not a problem at all, because this only does it for I less than num names. Num names, number of names is 1, so it's going to do 1 copy, right? So as a result of this for loop, we copy this address into here, so this thing now points there. Man, we got pointers going everywhere, don't we? But we can still decipher this, we can still track it. So we got this copied, and now we go to the next one. We're allocating a new chunk of memory. Notice that token pointer doesn't point to Mary anymore, but Mary